Hi there friends, welcome back to the channel. In the previous episode, we discussed opportunities for electrical design engineers working in the power systems industry within the low voltage space. In today's episode, we are going to discuss opportunities for electrical design engineers in power systems industry within the medium voltage space. Most of the codes and standards have a demarcation of 1000 volt as the difference between low voltage and medium voltage. And typically above 1000 volts, everything is considered as high voltage. From application standpoint, voltages between 1 kV and roughly 15 kV are considered to be medium voltage. Now, there are tons of opportunities for electrical engineers within this bandwidth of 1 kV and 15 kV. As I mentioned in my last episode, low voltage design engineers are typically operating in the residential and commercial space. These electrical engineers who are working as power systems engineers typically interact with architects and mechanical HVAC engineers. But when you start operating in the 1 kV to 15 kV bandwidth, you get to interact with a lot of other disciplines as well. Because more often than not, you will be in an industrial setting. It can be a petrochemical plant, it can be an infrastructure project, it can be an energy project, metals, mining, renewable, oil and gas, pulp and paper, shipping, and so on. Let's take oil and gas as an example. If you're working on a capital project for a client who operates in oil and gas, as an electrical design engineer, at the medium voltage level, you will most likely be working with transformers that are MV, substations, including a combination of a transformer, high voltage switchgear, and a low voltage switchgear. You might be working with medium voltage motors, VFDs that are medium voltage, battery backup, UPS, generators, emergency gensets, medium voltage cables, area classification diagrams, synchronous motors for special applications, lots and lots of pumps, MCCs, and other specialized electrical and mechanical equipment like these. Now, as you can imagine, when you compare this space with residential and commercial, you have big ticket items, much more heavier duty stuff. You're no longer working with a 45 kV or 100 kVA dry type transformer. Most likely you'll be working with oil filled transformers. And that is just a start. These transformers can be special dual winding. You may have to install them in vaults, in basements, indoor, which will basically kick in additional requirements from the codes and standards standpoint, or they may be installed outdoors as part of a substation assembly with a high voltage switchgear and a low voltage switchgear all combined and coupled with the transformer. Now, talking of switchgears, they can be of so many different types. Your high voltage switchgear can have a breaker, which will make it quite expensive, or it can have a fuse as a protective device. On the low voltage side of things as well, there can be a variety of configurations for the switchgear. The transformer itself may require K-factor rating. It may require special type of construction due to the clearance requirements, because a lot of times if you're working especially in a brownfield in an existing environment, then space is a big consideration. How do you terminate cables on the transformer? Do you go above ground? Do you go underground? What type of routing mechanism are you going to use? And that is just at a very high level. Sizing these transformers, figuring out the right MVA MW rating, identifying whether you need external cooling, and then writing equipment specifications, going out for bidding, evaluating the data sheets that you receive from multiple vendors, leveling the bids, and then presenting to your client the right technical option, and then following that through with installation support, commissioning support, and startup. I'm using a transformer as an example because that is the heart and soul of power system, but you'll have to rinse and repeat this process with low voltage switchgear, with high voltage switchgear, with industrial UPS systems, battery chargers, variable speed drives, motor control centers, cables, raceways, lighting systems, and the overall power distribution scheme. And remember that you are not working in isolation. If you provide incorrect or incomplete information to civil and structural engineers, and they assume that this is the final detail, and down the road weight doubles up, and they haven't taken that into consideration in terms of the foundation design and their calculations, then I have heard of horror stories where entire foundation had to be removed and poured again. You can see that everything is interlinked, and that's what makes medium voltage electrical design engineering so interesting. And that's why electrical engineers who have a solid background in medium voltage design engineering are in such a huge demand, especially if you are a PE. I've written several books on the topic of FE electrical and PE power exam preparation, and I also run popular programs for FE electrical and PE power prep. If you have a track record of working on and delivering excellent projects as an electrical design engineer with expertise in medium voltage design, and on top of that, if you're able to get PE credentials, you will be in huge demand because there's so many industries, as I mentioned early on: mining, metal, energy, infrastructure, renewable, municipalities, states, public and private sector. Regardless of the geographic location, which city or state you are in, electrical design engineers with MV experience are always going to be in demand. But in order to make yourself marketable as an electrical design engineer within the medium voltage space, you need to accumulate hard skills that are portable. And accumulation of these hard skills takes time. Maybe combined with a graduate degree is just a starting point. You need to get meaningful experience in the field. And on top of that, if you can seek the credential as a PE, you'll be in huge demand. Let me know what you think about this video. If you have any comments, questions, or suggestions, please share them. I really appreciate if you could like this video and subscribe to the channel. In the next video, I'm going to discuss opportunities for electrical design engineers in the high voltage space. Thanks for your time. I'll see you again. If you like this video, then please don't forget to subscribe to this channel. Feel free to ask me any questions in the comment section of this video below. You can find tons of success stories of my FE Electrical and PE Power students over here. And if you want to learn more about preparation of FE Electrical and Computer exam and the PE Power exam, then check out these playlists over here. Thanks for watching, and I'll see you soon in the next video.